Good morning to all of you. Welcome back to the channel once again, that is on JE Physics Maniac. So, today we are going to discuss a very interesting case. This case entails the discussion of physics, and with the help of another subject which generally maintains 180-degree out of phase relation with physics, that is biology. Uh, I have no hesitation to announce that I'm a good quality dumb in biology, but for the sake of this problem, I have started reading and learning. So, without wasting much time, let's proceed. So, here the question is saying the specialized bacteria can be found living in quite unattractive places, such as wild and sewage disposal plants. A bacterium is actually singular number of bacteria that lives in an absolutely dark and essentially homogeneous soup faces serious navigational problem if you must sometimes rise for oxygen and then descend for an important part of its dinner, which way is up. One class of bacteria has solved the problem by incorporating an iron oxide magnet inside its cell. Discuss the following questions quantitatively, making clear the nature of necessarily through approximation used. Okay, why not the sense of pressure gradient in the fluid instead of using a magnet? And then they are saying estimate the minimum magnetic moment that could be used to line up the bacterium, and assuming 10 to the power minus 4 centimeter for the length of the magnetic needle, estimate its minimum diameter. So first of all, when we are talking about navigation through that's saying the pressure gradient, the problem is that the navigation of pressure gradient depends on a particular factor, that is the density of the corresponding bacterium with respect to the liquid in which it is traveling. If the liquid density is more, then it will have a different consequence. If the liquid density is less in comparison to the relative density of the bacteria, we will see a completely different scenario. So that's why this particular what can I say way of magnetization of things is being used. Now, I know that if you are coming from specific hardcore physics, chemistry, math background, it is very difficult for you to imagine about how a bacteria is developing this magnetic property. But let me tell you, there is one particular specific category of bacteria which is called iron oxidizing bacteria. They do develop these kind of things, and in this page you can see I have kept few diagram also. But before going into that, I will name a few iron oxidizing bacteria like Spherotillus, Crenothrix, Leptothrix, Gallionella. These are the names we are iron oxidizing bacteria. So what they basically do, they oxidize ferrous ions into ferric state to obtain their energy basically, right? As an example, you can imagine that there is another type of bacteria which is basically called Acidithiobacillus, which was earlier known as Thiobacillus also. What they do, they oxidize iron and generate electron, which finally go into the terminal electron acceptor through electron transport pathway, and this particular mechanism helps them to develop or generate energy with the help of enzyme efficiency, right? So it's not nothing new, it is already there. So as an example, as a proof, you can see that I have kept one diagram over here. Here you can see that there is a mechanism going on to remove the supernatant with the help of magnet. You can see the magnet is here, right? So that means those bacteria have a magnetic property in them. There is another diagram also that I have kept over here. You can check that this is basically a liquid biopsy analysis using surface enhanced Raman spectroscopy, in which through using a magnet, the incubation time is being separated and the bacteria are being separated from one another. Okay, right. So basically what the physics will follow here, that there is a magnet present inside the bacteria which can help them to rise or fall. Now this rise or fall will depend on the relative orientation of that magnet with geomagnetic field of the earth. Now orientation of the magnet will be decided by the orientation of the magnetic moment, magnetic dipole moment. Either the magnetic dipole moment can be in anti-parallel direction to the geomagnetic field of the earth, or it can be parallel to the geomagnetic field of the earth. So based on that, they can move up or they can come down. Now the next question is, this relative orientation of the geomagnetic field of the earth, how it can decide whether they will move or down? Yes, they can decide. Since the earth's magnetic field is not uniform, it is non-uniform. So we know whenever a magnet is kept in a non-uniform magnetic field, it will experience a force F vector. I can put it in vector format also. F vector is equal to mu vector del B del Y. Right? Now, y is the height taken from the earth's surface. So as you move up, B decreases, so del B del Y becomes negative. So F can be upward or downward on the basis whether mu vector is in direction of del B del Y or it is anti-parallel to del B del Y. Now I hope it is clear to everyone, right? Okay. Now here another note I have written, that is they do follow, the bacteria do follow Brownian motion, that is to and from motion, and due to that random thermal motion, what happens, the bacteria can move up and down. The magnet of the bacteria, now it is not about a single bacterium, it is all about the bacterias, they are clinging together so that the tiny magnets inside them, they are aligning in such a way so that it form a big magnet with magnetic moment mu, right? And the next question, we know that whenever two magnets are being kept side by side, like here I'm assuming that there are two bacteria which are aligning them end to end position. So in that case, the interactional potential energy U is equal to given as minus mu vector mu2 by r cube minus of 3 into mu2 dot r by r to the power 5 into r vector. And remember, this I have expressed in CGS unit. If you write in SI unit, one constant of proportionality mu naught by 4 pi will come. But since I have taken this magnetic moment to be mu and this magnetic permittivity again will come mu naught. So to avoid confusion, I have kept it in CGS unit. So don't worry, if it is coming in the exam, you can safely put the value mu naught by 4 pi V naught 10 to the power minus 7. Now, so here, now what we are going to assume, we are assuming that these two are likely magnets, there are two bacteria, and for there the magnets are identical. So for which mu1 equal to mu2 is equal to mu. And if I substitute this value over here in this equation, it will come that U is equal to 2 mu square by r cube. Now, since they are in Brownian motion, so their motion is in random thermal motion, so we will follow KTG, and for that the order of energy that a single bacteria will have is KT. So 2 mu square by r cube will be KT and mu will be equal to root under of KT r cube by 2. So this is the magnetic dipole moment of bacterium, right? Now this small m factor here that I have written to be mu vector. So I will change this value here since I have taken it to be mu. So mu is equal to, you can write pi r square L. L is the length, r is the radius of cross section, and m is the magnetization vector, correct? So I can put the value, so mu is equal to pi r square L into m, and taking T is equal to 300 Kelvin at room temperature, I can specifically calculate the value of R here because everything else is given and standard value of M will be supplied. R comes to be 10 to the power minus 6 centimeter, correct? So this is one way of seeing things in a different perspective, and rightly we say that physics is everywhere, right? So even in a small bacteria also we can understand this thing with the help of physics and with the help of the understanding in magnetism, how the bar magnet operates, right? So I hope you have enjoyed. So this is a very interesting, very interesting thing, and obviously you can do a further research on this topic. You can study things, they are interesting. If you do like this particular question, then please do subscribe, share, and hit the like button. Thank you. Thanks all.